Assalamu alaikum students. Hope all of you are fine by the grace of Almighty Allah. Welcome to our today's science class, and today I will start a new chapter, chapter 8. The name of this chapter is mixture, and we know all matters are made up of some very tiny particles which are known as atoms or molecules. And these matters are mainly classified into two types. One is pure substances and another is mixtures. Okay, and these pure substances also can be classified into two types. One is elements and other is compounds. And mixtures also can be classified into two types, which is homogeneous mixture and heterogeneous mixture. And homogeneous mixture is also known as solution. Okay, and there are some examples, but these are the particle arrangements of these different types of matters. Okay, but I will discuss about that later. And at first, I will define the all types of matters. Okay, one by one, and you can observe easily. At first, I will define the element, and element is a pure substance. Okay, element is a pure substance that cannot be broken down into a simpler substance, okay, by any ordinary chemical changes. Okay, and these elements are the matters that are made of only one component, like iron. In iron piece only iron are present. Okay, and if you consider any gas, oxygen gas, and nitrogen or helium, then they all are element. If this if we divide or break down these elements, then you will find only these elements. Okay, and that's why this is known as this is a pure substance. And other classification, other type of pure substance is compounds. And a compound is a substance made up of two or more atoms bonded together. Okay, this is the important term. The two or more types of atoms bonded together, they are chemically bonded. And then the example is here mentioned water molecule. Okay, water is a compound, and you can easily observe from the chemical formula of this compound. And every compound has a specific chemical formula, and for water this chemical formula is H2O. That means from this formula we can easily observe that in that two different element is present. One is hydrogen, two atom hydrogen, and one is oxygen. Okay, one atom oxygen are chemically bonded to form of water. Look at this picture. This is the arrangement in this this is the arrangement of atmosphere air. Okay, and we know air is a mixture of elements and compounds. Air is a mixture, and in that both elements and compounds are present. Different elements. Look at this molecule. Nitrogen and nitrogen are bonded, and this is a elemental molecule. That means this is the element. And if we break the nitrogen molecule, we get only nitrogen. Okay, and this is the oxygen molecule, but this is carbon dioxide molecule. Okay, CO2. In that one carbon atom are bonded with two oxygen atom. That means this is a compound. And this is the water, vapor water. In air we know water is present as vapor phase, gaseous phase. and in this molecule, one oxygen atom is bonded with two hydrogen atom. That means it is a compound. Okay, that means this oxygen, nitrogen, they are elemental molecule, and these are compound molecule. Okay, and now if compounds can be broken down into simple substances. Okay, that means if we break water molecule, you get two hydrogen atom and one oxygen atom. If we break carbon dioxide, you will get one carbon atom and two oxygen atom. Okay, I think it is clear what is compound and what is element. These are the classifications of pure substances. And now I will go for another matter, which is mixture. Okay, and mixture is a combination of two or more pure substances. Okay, and this is the combination of two or more pure substances that are not chemically combined. Okay, they are not chemically combined. Okay, these substances held together by a physical forces. Okay, not chemical, and that's why we can say no chemical change takes place to making any mixture, and to make any mixture, and each item of each constituent components of any mixture retains its properties, okay, in the mixture. uh, that means the components each keep their original properties in the mixture, and they can be separated physically. Okay, and they can be easily separated by physical methods like heating, crystallization, evaporation. Okay, okay, and distillation. Okay, and you can see the picture here. This is the tap water. We know tap with in tap water with water molecule, other substances are mixed up, and that's why we distill the tap water, and we get pure water. This picture, this is the pure water. This blue circles shows the only pure water molecules, but in this tap water there are these colorful circles other than blue, means the presence of other substances, but they are not chemically bonded with water molecules. Okay, and that's why they can be easily separated by any physical method, by applying any physical method. Okay, like heating, or look at this process. This is a block, this is a mixture, solid mixture, and if we crush this, they convert into dust particles, and if we melt them, they can be totally separated from each other. Okay, and we can get our component, individual component. Okay, and that's why mixtures are an impure substance. We can say that mixtures are an impure substance, and they have no chemical formula. Okay, they have no definite chemical formula. They can be mixed in any ratio, and the properties of the mixture are the properties of its constituents, components. Okay, and this mixture can be classified into two types. One is homogeneous mixture and another is heterogeneous mixture. And look at this picture. This picture will show you the difference between mixture and compound. This is compound. Here three different atoms, three different elements, atoms are bonded. This line means represent the bond. Okay, they are chemically bonded to form a new compound, to form this compound. But in this is a mixture. In this mixture, three different components are present: green, two yellow, and one blue. Okay, and they are physically held. Okay, they are held together by physical forces. They are in the same container, same place, but uh, this is a physical combination. There is no, you can easily observe that there is no bond between these components, okay, and component molecules, and this is known as mixture. And now we go for the homogeneous mixture. The mixture whose components are distributed evenly, okay, evenly, that means uniformly, and whose components can be easily separated from one another are called homogeneous mixture. That means in this type of mixture we cannot distinguish the components, okay, they are mixed, they are distributed evenly in all places, okay, and uh, and that's why it cannot be easily separated from one another, okay. It can be separated but not easily separated, okay. And these are some examples. This is the purees. Different food items are generally mixtures, we known as mixture, okay. Puree is the homogeneous mixture, and homogeneous mixture is known as commonly solution, okay. And this coffee, they are mixed together, all the components are distributed evenly, and this is milkshake, cold tomato soup, chocolate, orange juice, all are homogeneous mixture. And now the heterogeneous mixture, these mixture whose components are not the mixture, heterogeneous mixture are those whose components are not distributed uniformly, okay, in the mixture, and the components can be easily separated from one another, okay. And you can easily distinguish all the components, okay, visually, okay. And look at this, this is a fruit salad. We can easily separate from this mixture every components, okay. Every fruit piece can be eliminated, we can pick from the mixture. And this is a salad, this is milk and cereal, this is also can be easily separated. And this is chickpeas, okay, spicy mixture. And from this if we some portion from some of some of mixture from any portion, then we will get some components more and some components less in amount, okay. And that's why these mixtures are known as heterogeneous mixtures. And now uh, we know about uh, homogeneous mixture, that means solution. And what is solution? A solution is a mixture where one of the substance dissolves in the other, okay, dissolves in the other substance, and the substance that dissolves is called the solute, and the substance that the solute dissolves in is called the solvent, okay. And the solute and solvent makes the solution, okay. When solute dissolves in solvent, it makes solution. And from the solution and by crystallization we can separate the solute and solvent again, okay. This is a reverse process, reverse change, okay. And now take an example, mixing salt with water, okay. For example, salt and water. If we take salt and add 1 spoon of salt, add with water, and mixing up properly, then we get a solution, okay. And in that solution all the particles of solute are uniformly dispersed, uniformly distributed all the place of the solvent. Okay, and these components also can be separated by evaporation, and they each retain their original properties. Okay, after separation. Okay, we get the salt with original properties of salt, and we get pure water. And solutions of different concentrations this is another example. We can make a water sugar solution by using sugar as solute, and water as solvent. Okay, and a solution of different concentrations can be produced by mixing more or less solute and solvent in the solution. Okay, that means the solution is called dilute or concentrated, depending upon the concentration level of the solution. Okay, and let us make and the definition of the concentration of solution is the amount of substance, the amount of solute per unit volume of the solution is known as concentration of the solution. And this is similar, concentration is the similar word of density. Okay, density and concentration is similar, have similar meaning. In for solution we use the term concentration. Okay, and that means concentration shows us how densely distributed the particles in any solvent. Okay, and in any solution. And now and the property of solute to dissolve in a solvent is known as the solubility. Okay, and that means a solute is dissolved in solvent, and this property of that solute is known as solubility. And now now, I will show you an experiment. Let's do an experiment to make concentrated and dilute solution, and differentiate them. Okay, and for that, at first, we have to take two beaker, and then take 100 gram of drinking water in this beaker. Okay, in these two beakers. Okay, in using a measuring cylinder. Okay, and 1 spoon, then pour 1 spoon of sugar in one beaker and 3 spoon of sugar in other one. Okay, and then stir them gently to dissolve this into the solvent. And now taste the sweetness of the solution. Okay, now taste the sweetness of the sugar solution, and then by taking 1 spoon from each beaker. And then but for the you have to careful about that. The for sugar solution it's not problem, but the majority of chemical substances are injurious to human body, so it is not wise to test by drinking or eating any solution or chemical substance without thoroughly knowing about them. Okay, but we can test sugar solution easily. And then the beaker in which 3 spoon of sugar were added has the mixture that tastes sweeter. Okay, and then and out of these two solutions of same volume we take same volume of solvent. Okay, and same volume of this out of these two solutions, and the solution which one has comparatively more amount of solute is called concentrated solute solution, and the other solution which has comparatively less amount of solute is called dilute solution. And now again we can if we the same amount of salt, if 1 spoon of salt is mixed in two beakers, containing containing more amount of water in one. Okay, that means one in 100 ml, but another is 200 ml water. Okay, and then the solution containing more water is dilute solution, while the one which less water is concentrated solution. Okay, that means the solution with less amount of water is concentrated solution, and the solution with a higher amount of water, that means solvent, is dilute solution. And that's actually there is no specific rule to determine which is dilute and which concentration, which is concentrated solution. Okay, and now we can summarize this in this. We can define the dilute and concentrated solution. A dilute solution has some small amount of solute in a large amount of solvent, and a concentrated solution has a large amount of solute in a small amount of solvent. Okay, and this picture, these two beaker shows you the particular arrangement, the particle of solute. Okay, the particles of solute in solution. Okay, and for these two beaker, the volume of liquid are the same. Okay, and now is you can easily observe that in this dilute solution, in dilute solution, the solute, these circles are represent the solute particle. Okay, solute molecule, and these solute molecules are less, very less few in amount, but in this concentrated solution, the particles of solute are more in amount, and they are more dense. Okay, and that's why they are called concentrated solution. Okay, and that means the concentration of the solution is more, that means the density of the solution is more in this container, in this beaker. And mm, and now look at this picture. This picture is showing you the different solutions with different salts. Okay, different chemical salts. This is zinc sulfate, and you can observe from this four beaker, there are these A and D contains colorless solution, and these two, ferrous sulfate and copper sulfate, is contains, that means iron sulfate and copper sulfate contains colorful solution. Okay, and it is not possible to say whether a colorless watery solution is dilute or concentrated by taking a look at it. Okay, but in case of colored solutions, for these two, B and C solution, in case of colored solutions of different concentrations, it is possible to say which one is dilute and which one is concentrated by looking at them. Okay, and now we will see how we can differentiate between concentrated and dilute color solution. Okay, and look at this pictures. This is for doing this experiment, and we need copper sulfate solution, copper sulfate. Okay, and this is copper sulfate salt. Okay, this is the crystal of copper sulfate, and this is the powder of crushed copper sulfate, and you can see that beautiful blue colored crystal. Okay, and this copper sulfate salt we have to need for this experiment, and this is for this experiment, this is the solute. Okay, Uh, this is the solute, copper sulfate salt is solute here, and now we have you can see this picture. This is picture show you the two solution, and these two solution is a copper sulfate solution with water. Okay, and now uh, for this preparation, for this arrangement, for this experiment, we have to take three clean test tubes. Okay, and take 5 milliliters, 5 ml of water in each tube. Okay, for each tube, we have to take 5 milliliter of water, and now add in the first test tube 1 spoon of copper sulfate. Okay, and in the second test tube 2 spoon of copper sulfate, and in the third spoon 3 spoon of copper sulfate. Then shake the test tubes well till the crystals of copper sulfate are completely dissolved, and then again set the test tubes at their own place. Okay, and now do all the solutions look the same blue color, students? No, and the solution looks less blue in which we added less copper sulfate. Okay, this first one. Okay, and this means it is less dilute solution. Okay, this is dilute solution, and in this way, as we increase the amount of copper sulfate, the color of the solutions gradually become deeper. We can observe that gradually color gets deeper as concentration increases. Okay, and that means the solution have become more concentrated from diluted with the increase in the amount of copper sulfate. And you can now differentiate between dilute and concentrated solution by preparing a solution with potassium permanganate and potassium dichromate in the same way. Okay, look at this uh, picture now, and this picture shows you the particle arrangement. Okay, the particle of solids arrangement. Okay, this is lighter, this is more dense solution, that means dilute solution. In this, the particle of solid are more dense than this one, and these are highly concentrated. Okay, and now we can prepare this using potassium dichromate. We can prepare different solutions with different concentrations, and this is the crystal of potassium dichromate, a dark violet color, and if we add is potassium dichromate in water, then they are dissolves like that, and there are in the pictures, there are the solutions of different concentrations. You can easily observe that, and you can easily identify that which one is dilute solution and which one is most concentrated. Okay, and now this is the potassium permanganate solutions of different concentrations. This orange color crystal is potassium permanganate. Okay, and this is from this picture we can easily observe that this is light uh, color, that means it is dilute solution, and this is concentrated solution. Now that's all for today, students. Assalamu alaikum.